Okay, so Naomi, if you'd like to go ahead and introduce our speaker.
I will. Actually, we have several VIPs on this meeting from Muscatine Power and Water, including our speaker, Doug, and our guest, Gage, who will be introducing Doug here in just a minute. I see Sal LoBianco on the call and also Erica Cox. So we have a good representation from our community leaders here. I'm just going to tell you a few things about Gage, who has, of course, succeeded Sal just a couple of years ago as the general manager of Muscatine Power and Water. And he's been with Muscatine Power and Water, though, since 2003, when he started as an engineer at the power plant. He also held leadership roles in operations and maintenance. And in 2011, I'm sure Sal had something to do with this. He was asked to join the senior leadership team as director of power production and supply. And in that role, he was responsible for securing the most economical power for our customers through our local power production, or securing energy from the external energy market. Gage grew up in the area here, not too far from Muscatine in Durant, and is a graduate of University of Iowa, both bachelor's and master's degrees. And so I know Gage is a friend to many of us here on the call. So I'll ask you, Gage, to just kind of introduce the subject and then also introduce Doug specifically. Thank you.
Absolutely. Thank you, Naomi. And yeah, with Sal on here now, I really got to be careful and make sure we get all the facts right, because he'll be able to check up on us. And I think when you said Sal had something to do with my move to the senior leadership team, I think the term was took a huge risk on promoting me at a young age, but hopefully, it's working out okay. But thank you all very much for letting us attend and present to you today. We had asked for an opportunity to present to this group because Muscatine really is on the cusp of a major transition in how we get our electricity. Having reliable electricity has just really become something that we take for granted anymore, and that's a good thing. As the industry continues to make changes in how electricity is produced, it's very important that MPW evaluates what changes we make that make the most sense for Muscatine specifically, and also ensure that those changes continue to provide the reliable services that we have come to expect. A lot of folks have ideas on how we maybe could produce electricity in the future, but we're the ones that actually have to deliver it and ensure that our homes and businesses continue to have that reliable service in the years ahead. In these situations, I think it's just where municipal utilities really shine, because as a nonprofit municipal utility, we only focus on what matters most for Muscatine. There's no profit motivation to cloud any decisions. We don't have to worry about balancing priorities in different states and different communities. We focus on Muscatine and making decisions for what's in the best interest of our customers here locally. So I think that's just a perfect time when you face these major transitions to have a municipal model. So today, as Naomi mentioned, we'll get to hear from a gentleman who will play a very key role in that transition of energy supply for Muscatine, Doug White. Doug's been serving Muscatine for a long time. He started at MPW back in 1988, and he served in various technical roles in maintenance and operations, as well as leadership roles over the past 30 plus years down at our power generation facility. And Doug moved into his role now as the Director of Power Production Supply about a year ago, roughly. And in this role, he oversees the safe, efficient, and reliable operation of our power generation facilities, and also manages our relationship in that wholesale electricity market that Naomi mentioned, as well as oversees our environmental affairs. Doug oversaw our last power supply study that we completed last year that he'll talk about, and he'll be leading our efforts and our initiative we're calling Powering the Future as we look to making the transitions that we talked about. And with that, I'll turn it over to you, Doug.
Thanks, Gage. I think I might be blushing a little bit. That was that was pretty big. I appreciate that. And I'm just going to step right into this slide deck. We've got a pretty thick deck, and it's going to run it right up to the end of the time. Let me see if I can get this thing rolling. Is everybody seeing that full screen?
Yes, Doug, looks good.
All right. Hey, thanks a lot. Appreciate that feedback. So in my office here, I've got Ryan Streck with me as well. We've got all the heavy hitters here. He's here to, in case we have some, he's the Director of Utility Service and Delivery. And he's sitting in to help out if there's any questions about his department. And I really appreciate you guys taking the time to listen to this presentation. So I'm going to talk a little bit about history, the bulk electric system, our current generating assets, the most recent power supply study and recommendation, and to maybe share a little color about that latest polar vortex or winter storm that we went through. Seems a little distant to when you walk outside at this point. So in the beginning, the earth cooled. Well, let's not go quite that far back. We don't have time. So we'll start with the electric utility when it was established in 1922, and it was called the Muscatine Electric Light Company. That utility was formed in response to local concerns about poor service from the privately held electric companies. And that was a common theme with the water utility. And most of us probably remember the communication utility, big drivers for moving ahead. So since then, reliable, low-cost energy has been a building block and an economic advantage for the community for nearly 100 years. Fast forward to 2009, when MPW becomes a member of the Mid-Continent Independent System Operators Wholesale Market. Let's call that MISO from now on. So this is a picture of the Miso Footprint and extends all the way from Manitoba clear down to southern Louisiana. Being connected to this Miso system provides a redundant supply of energy for us, and it also helps us support the bulk electric system reliability. So Miso's role is to balance the system energy flow and supply energy to each connection point at the lowest cost. I think it's really important to note that the price of energy is not the same at each point in the Miso system. It's driven by the cost of supply or generation and demand, which is the load, along with transmission constraints and congestion. The system is very dynamic and pricing changes every 5 minutes. One of the advantages we have of our local system is that we're connected into the market at the same place, we generate in at the same place that we purchase from. So this works as a power market price hedge. We can sell excess power into the market when the price is high, or reduce generation and purchase out of the market when the prices are low. This flexibility ensures MPW customers are supplied with reliable energy produced at the lowest cost. So in 2020, the bulk of the power was generated by Unit 9 due to its higher efficiency. You can see it's nearly 70%. We've also got Unit 8A. It also has a very high efficiency and capacity factor, a relatively small electric output. The steam sales from that unit, the 8A, which is a combined heat and power unit, that's really been a mutually beneficial and has reduced the utility's overall operating energy costs for over 20 years. This benefit really helps us stabilize rates. In 2020, the 8A produced about 2.1 billion pounds of steam. So back in 2016, this was one of Gage's projects. We began incorporating renewables or wind into the power portfolio with energy produced by the 13 megawatt South Fork Wind Farm. South Fork Wind Farm, it produced about 8% of the energy for MPW in 2020. And as a renewable resource, the South Fork Wind Farm produces one renewable energy certificate, or REC, for each megawatt hour produced. MPW's Choose Green program is a tool that brings renewables from areas capable of producing it, like the South Fork Wind Farm, to areas that are not, which is right around Muscatine, through the sale of these RECs. And the REC sales increased dramatically in 2020, and that's really showing an increased interest in renewable energy. So power supply study is a big project for us. It started in 2019 and we finished up in the spring of 2020. So why do we do these things? The power supply studies help us plan for the future. The power system changes, all power system changes involve a great deal of time, planning, and a lot of money. These are big ticket items. Performing these studies gives MPW a blueprint to make sound decisions to continue providing reliable energy and reliable low-cost energy for decades to come. This is a 20-year span that this looks at. So in particular, a couple of the major drivers were it's just industry best practice to perform these studies every 3 to 5 years. We've seen a lot of declining natural gas prices that have been sustained low, and they're impacting the coal generation dispatch. Also, cost declines and technology improvements in wind and solar. And we've got some encroaching environmental compliance deadlines and associated costs for our existing units. So the previous study was completed in 2016 and recommended a new 161 kV transmission line that'll offer us a redundant power supply. Project planning is now complete and construction is actually going to begin this year. The completion of this line will allow us to retire plant 1, or collectively units 7, 8, and 8A. It's one of Ryan's projects for this year. So you can see 2016, 2021 to get this project rolling. These are long-term decisions. So the study was completed by an outside engineering firm using a statistical modeling analysis software designed especially for this. This comprehensive analysis used 20 different portfolio scenarios and evaluated under 4 different market cases or sensitivities, which resulted in nearly 4,000 potential outcomes. The software's goal is to determine the lowest cost and risk portfolio to serve Muscatine's native system load for the next 20 years. But there are things that are outside that study. It focuses on the cost and price risk. Local factors include system reliability, which is paramount for us, local system control, and this local economic impact, as well as environmental considerations. So study of the recommendations are, in the simplest terms, the study recommend MPW consider transitioning to a more efficient and cleaner energy sources, which include the expansion of renewables and a switch from coal to natural gas. The study also recommends diversifying our portfolio and leaving an open position for future additions as technology changes. More specifically, the study recommends 30 megawatts at the Solar Grandview Wellfield site, and then explore an additional 30 megawatts at the same time off that site. We're going to be evaluating the economics of a new gas-fired combined heat and power unit and a potential steam cell extension. We're also going to be planning for the retirements of units 7, 8, and 8A in 2023. And we'll also be tentatively planning for their unit 9's retirement in 2028. So here's the timeline for you. The solar was selected as part of the portfolio because of the known costs over time, and that acts as a pricing hedge. You don't have the fluctuations of fuel. But so this high-level timeline illustrates the milestones and multiple board decision points. We've already started this investigation process and believe that the project could be completed before 2024. We're lucky enough to have a unique site with natural gas transmission running right across the generation site, a local steam customer, and MISO interconnections that allow us the option of combined heat and power. Combined heat and power is endorsed by the EPA, the Department of Energy, the Iowa Economic Development Authority as one of the most efficient ways to use natural gas. This high efficiency led to study conclusions towards the CHIP option. This high-level timeline for the CHIP project lays out major steps and multiple board decision points again. The development timeline would be 5+ years for this project. So in keeping with our core value of environmental stewardship and protecting the land, water, and air to the best of our ability, the proposed energy portfolio makes sense. Decreasing our carbon footprint will have a positive, long-lasting impact on the environment. We expect to see a 25 to 30% reduction in CO2 emissions from the retirement of Plant 1 in 2023, and a 60 to 70% reduction with the shift from coal to natural gas in 2028. As our power supply transitions, we'll also see reductions in NOx, PM10 and 2.5, along with reduced water use from both the river and the aquifer. So by the numbers, here's the key piece. As modeled, there isn't a significant difference between the power supply study recommendations and maintaining Unit 9 with the anticipated environmental costs. Here are the key pieces. So back when Sal built Unit 9 in 1980, the cost was about $250 million. Sorry, Sal, I know you're on the call, so I had to throw it in. In today's money, it cost about $680 million to build the same thing. So it gives you a feel of scale. These are big things. The solar array would likely come in the form of a PPA with a solar developer. So this would allow us to see some of the benefits of the federal investment tax credit. So as a municipality, as a municipal utility, we don't pay taxes and we can't monetize that tax credit. If we were to do a design build, the capital for this 30 megawatt array would, I'd estimate, between $40 and $50 million to do that project. So in the power supply study, the chip unit was modeled at 120 megawatts and a cost of about $133 million. So currently we're working with Stanley Consultants and they're investigating units in the 50 to 110 megawatt range to find the best size for Muscatine. So the cost could be less. The environmental compliance costs for our existing units are over $40 million and are expected to change with the current administration. The environmental compliance timeline for our existing units is really driving this project schedule. Unfortunately, the retirement of Plant 1 is going to come with staffing reductions of between 25 and 30 employees. Staffing reductions will come through natural attrition, retirements, job transfers, and ultimately phased layoffs. Currently, Plant 1's fixed O&M costs are about $7.8 million a year, and much of this will be local impact. So one of the questions that comes up quite often, especially in the climate we're in now, is what about 100% renewables? What would that take? So we could overbuild our generation resources to target this annual energy production. Now I did it. Oh. Look what Doug can do. Sorry. We could overbuild our, well, there's a button somewhere. One more time. So we could overbuild our generation resources to target an annual production equivalent to our native system needs. So this is the scenario that the Des Moines City Council has announced. So our power supply team's actually been penciling out a scenario like this to get a feel for what the cost would be here at Muscatine. So Muscatine needs about 924,000 megawatts a year. To achieve 100% renewable offset energy, we need about 450 to 500 megawatts of installed solar to match our annual system demand. The difference between the installed capacity and the actual solar output is the solar capacity factor, which is about 25%. So that means if we install 100 megawatts of solar, we're actually going to get about 25 megawatts, an average of 25 megawatts out of that solar array over the year. As comparison, a natural gas or coal unit typically has a capacity factor greater than 90%. So it takes a lot less installed capacity to cover that same load. That 450 to 500 megawatts, it costs between $560 and $625 million, and it cover about 4,000 acres. So the next scenario is, okay, let's just say we want all renewables. We're going to have enough solar to charge batteries to get us through the night, and we'd have enough energy to cover our whole system load to do that. So to get to that level, we would need about 870 megawatts of solar to supply the native load, and that would be enough to make the 924,000 that we need a year. And we'd need a bank of about 150 megawatts of batteries. And these batteries would have to store about 14 hours of energy, or a little over 2,000 megawatt hours of energy to get us through the night. And this graph that I have often here to the right really shows a day in December that shows that scenario. The batteries in the center of the orange section, this is the batteries or the solar panels covering the load, and the additional energy that needs to be produced to fill up the off hours. And the blue lines here, the blue bars, are the batteries charging or discharging back into the system. So that battery storage system would be about $460 million. But it also has to be turned over about twice in this lifetime. The solar array's got a lifespan of between 30 and 35 years. So these are lithium ion batteries, kind of like your cell phone. They're not going to last the 35 years. So we will be changing some of those out throughout so the O&M for the batteries is actually fairly high. It comes in at additional $770 million to keep those batteries up to speed. So as I'd mentioned, this is a stack bar chart that shows December. And when you go to June, you can see this orange or lighter orange area is over generation. So as I'd mentioned, the Miso system is a supply based on supply and demand. And we would be putting almost 500 megawatts of generation back into the system. It may or may not need it. And anytime you oversupply, you drive the nodal price or the price at our location down. So the price we get for it would be even less. And all of this information, the numbers I'm using are from the Department of Energy, the National Renewable Energy Lab. That's where I'm getting all this information from. And these are 2022 numbers. That's a division of the Department of Energy. Next, I wanted to share a couple observations from the Arctic storm. So this is Texas. We're probably all glad we weren't there. Unfortunately, there were people that were there. So looking over towards the left, and the investigation continues on the root cause of what happened in Texas. It's a lot of things put together, and there's a lot of finger pointing going on. But I thought that this chart really showed a kind of a good timeline and an example of what was going on with the generating resources at the time. I know there was a lot of finger pointing back and forth, but this trend doesn't lie. So starting over here on the left, you can see the green trend line represents the wind. So wind production was fairly high on Monday the 8th, and then that high pressure system came through. And I'm not sure if this was all cold related or actually the high pressure system brought in or just took the wind away, just like it did here. But throughout the event, you can see wind was off from its normal production. Solar is the orange or yellow line here at the bottom. You see the daily peaks of the solar. It also had trouble generating starting about Wednesday. I'm not sure if that was from the sun or whether that was from snow cover on the panels. Either way, both of those were off. You can see that the natural gas fired generation, it was trying to cover load at, actually covered load all the way until Monday, Tuesday, the 15th and 16th were the two coldest days of the event. And at that point, they had gas freezing issues and power plant freezing issues. Those units are not designed to handle those sort of temperatures. Most of the time, they're outside in Texas in the summer. A lot of them aren't even in a building or aren't in buildings just because of their location. And they had a lot of equipment failures, which really brought the system to where they didn't have enough generation to cover the load. And ultimately, the system control operators had to shed load by shutting off major circuits. The great part, actually, I thought the system, from the trends I've seen, the system control operators did a really good job of keeping the system from catastrophic failure. They were actually very close, and they did a good job of saving what they could. But unfortunately, all those power outages came with a lot of collateral damage. So what was happening here? Well, you may remember the 16th. You go outside today and you probably, it's becoming a distant memory quickly. But back on the 16th, it was cold. It's 5 degrees for the high that day. So you may remember this slide from the beginning. This is that Miso footprint again. This is I took a bunch of screenshots of the 16th. All the screenshots coming up were taken at the same time. And the screenshot shows that power prices. The purple nodes here are low prices in the system. The blue is about a normal price for us, which is 25 to 30 bucks a megawatt. And if you look down here at this Texas hub, it's over $1,000 a megawatt. And it's stayed like this for probably 4 or 5 days, the Miso map. This is a very unusual look for that map. I think one of the other pieces that it points out is how dynamic the market is. As you recall, I said that the price of energy isn't the same at each connection point. Each one of these little crosses represents a node or a location on this MISO map, and the pricing is very different depending on your balance of supply and demand. So for us during this period, had we not had local generation, our energy costs would have been about 10 times our normal costs. That local generation, and we had fixed price fuel on the ground, it really insulated for us from the high cost. And financially, it was actually a positive event for us, and won't impact our rates. The generation team did a great job of keeping the units on, as the communication utility, transmission and distribution folks and water department help keep all of our services available through this whole event. So here's a pie chart. These are all screenshots from the same time. This is what was producing the energy during that event, or on the 16th. You see the bulk of it was coal, natural gas, and nuclear power. We have wind in here, and then also some solar starting to show up on the pie chart. You see almost 90% of this comes from dispatchable resources. And that's a key piece when we start talking about reliability moving ahead, is that there's dispatchable and non-dispatchable resources. And dispatchable resources are resources that can help follow load. Non-dispatchables are intermittents and generally renewable. And they're kind of, you get what you get as you roll through you get what you get for output based on what's available for renewable energy. So here's a quick couple more graphs. The one on the left here, this is the system load, and this is pretty high load for the day, but the profile is fairly typical. Load goes up in the morning when business is open, and again, when people go home at night. The graph on the right is showing the wind output for the Miso Footprint. And you can see it fell off with the high pressure. And if you recall, it was really cold, but it just wasn't windy. And this really shows some of the challenges of matching generation and load with non-dispatchable or intermittent generation resources. So some of the benefits of local generation: we've got a uniquely high industrial load for a town this size that benefits the community as a whole. For these industries to maintain production, they've got to be able to rely on MPW to provide reliable, consistent power. Everybody at MPW takes this responsibility seriously because we know the positive economic impacts of these industries, our local businesses, and their employees on our community. Local generation provides high quality, reliable power and a hedge on the market. Local control decisions and making on those units operations. And it also has a substantial local economic impact. That combined heat and power has been a win-win for 20 years, and it's really benefited all of our customers through its high efficiency and it helps stabilize their rates. For us right now, we've got a really developed site, a well-developed site with available power, gas, and steam connections, along with that MISO transmission service. And we've got a highly skilled labor force ready to take on the challenge of a new unit. So the process to complete this power supply study, it was really complex and very comprehensive, but it's based on indicative price estimates. The actual costs and benefits of Muscatine still need to be vetted out. We're currently working with a consultant on our solar RFP, our request for proposal, to find out what that's, when the rubber meets the road, what is the actual cost here at Muscatine. The chip investigations going on with Stanley Consultants right now, and this is going to help us determine the best size and configuration for Muscatine. In the next phase, we're going to refresh the power supply assumptions, add the Stanley Consultant chip recommendation and solar pricing, and then we're going to rerun that stuff, all that new information, back through the Leidos power supply study model and validate those results. We plan to reach out to community service groups like the Rotary here to share what we learned from the study and discuss MPW's next steps in powering Muscatine's future. We're almost ready to launch a web page on the MPW website to house information related to this effort so it's easier to access. Despite the significant changes in MPW's future, the most important message is MPW is still here to stay. While the makeup of our power supply is changing, we'll continue to honor the commitment we made to citizens of Muscatine nearly 100 years ago to provide reliable, low-cost electricity to this great community. And we're open for questions. I know that was a lot of information, and that's, believe it or not, that's actually the short version.
That's the short version, actually.
The short version. And for Keith Porter, he's probably heard pieces of that several times. Sorry, Keith.
I'll go if everybody's silent, if that's okay, Rick.
Sure, go ahead, Vince.
All right, there's a ton of questions that were there. Was an excellent presentation also. So thanks, Doug. The one question I think I'll just hit off at the top. Instead of using 4,000 acres of what might be farmland or arable land for the solar wind farm, what would the possibility be of working with individual households to put solar arrays on many of the houses? And would that be a factor that would help MPW?
I can jump on that one, Doug, if you like. So in terms of cost, the cost for those smaller scale systems will be higher. So if you just said, we've got to try to accomplish that same amount of output, but on rooftops, the cost per unit would definitely be higher. So in terms of the impact on customers, that would probably be financially worse in the long run. Also, a lot of our load serves those industrial customers. We've got a lot of heavy industrial processes. And so there just aren't enough rooftops, on homes to serve that. That might help. That might make a big dent on the residential side, but to serve that other load would be a bigger challenge. But and mostly what we've evaluated is there's definitely a big economy of scale too. So when you put a utility scale type of system in, it really brings the cost down.
Thank you.
I'd also add that that's one of the nice pieces about the Grandview Avenue well site is that it is an existing well field. And although there is some agriculture on there, they're very limited about any chemicals that we can put on it. So it's a very low producing area. So it makes a pretty good site or a pretty good use, almost a dual use for that property.
Mm-hmm.
Excellent. Thanks, both of you.
I was just curious about, it didn't seem like with the ice storms that we had, there was a problem with distribution, but what does the utility do to deal with the ice storms and build up on power lines and stuff like that throughout the system?
Yeah, I think one of the biggest things we do is try to be proactive with our vegetation management. So, we evaluate our primary and transmission circuits on an annual basis and try and keep tree limbs cut back as much as possible. That's the biggest risk during those types of storms is a tree branch gets heavy, falls down and takes a line out. The lines are designed to handle a certain amount of ice buildup on them. And we have been, lucky to get through the last several ice storms really without too much of an impact. But those tree limbs are probably the biggest issue. And that's what we see at customers' homes a lot of times where a branch will break and take down the service to their home. And we get a lot of call outs for those situations. But that's probably the biggest thing we do to manage that.
Good questions. Thank you. One question that I had is, Doug, you mentioned that in Texas with what happened there, there are lots of people pointing lots of fingers in different directions. And, some of what we have heard, or that I've heard through the news was that, some of the failure may have been that their wind units froze because of the cold. And I guess I'm curious if there's a different type of unit that is used in Texas as opposed to in Iowa or elsewhere, or, you know, exactly why that would have happened down there.
Since Gage did the South Fork Wind Farm, I've got most of the answer, but since Gage was very close to that project, I'll maybe let him describe some of the differences between cold weather and warm climate wind turbines.
Yeah, so there are essentially kind of cold weather packages or add-ons you can do when you spec out a wind turbine project, and it includes different types of oil and gearboxes, things like that that are just designed to accommodate those colder temperatures. Now, a certain amount of ice buildup, they've improved the blade design over the years to be able to shed ice and not collect as much buildup in those conditions, but that is a risk in any climate. But with those additional kind of cold weather design specifications, they will be much more reliable in the winter than what Texas saw. And to Doug's point earlier with his trend, I think even if it wasn't ice related, one of the bigger challenges in Texas was the wind just wasn't blowing, you know, and that held a lot of the wind turbines from producing. Even if they were available, there just wasn't the wind resource. And you saw that big decline from 20,000 megawatts of output down to, in some cases, 1,000 during some of the coldest days of the event. That was probably the bigger challenge.
One last question, then I'll stop. I've lived in Indiana where it gets really cold. My daughter lives in Minnesota, ditto to that. Can Texas happen here? Oops,
I'm
wrong
sorry.
question.
I'm sorry. The audio was a little odd for me. I couldn't understand. I didn't understand the question.
Yeah, repeat
Sorry,
that.
since I've lived in areas in the grid that are extremely cold, can what happened in Texas happen here?
I think from what I'm seeing now from NERC, there's a lot of concern about the renewable penetration into the market as a whole. And it appears as though, you know, that gets a little trickier when you hit about 30%, when about 30% of the energy is produced by renewables, that it becomes a little trickier to have equipment that can back it up when it's not producing. As far as the cold and the turbines and stuff up here, they, you know, the wind turbines have, I know they have vibration monitoring equipment on them. So when they get out of balance, they'll actually turn the blade straight down and they'll heat that blade to shed the ice off of it. So those are some of the additional pieces that are put into equipment that are in this area that aren't in Texas. But in general, the higher the renewable penetration is into an ISO or independent system operator market, the more risk you have of reliability, or the more you have to overbuild the renewables so you have enough generation when the wind's not blowing or when the sun's not shining. If you put in enough panels or enough wind turbines, you can still cover the load, but that becomes really expensive when you start overbuilding. And then you have equipment that's not fully utilized when the wind is blowing. So it becomes a tricky balance of generation supplies and the types of assets you need to cover that load, because it still comes down to, you know, you have to make the energy has to be available at the moment that it's used. When the demand goes up, that very instant, you have to have generating assets to cover that load, or you get into frequency issues. And that's ultimately what just about tripped the whole grid down in Texas, was that they were under frequency, under 60 cycles a second. And from one of the trends I saw, they were about 4 minutes away from an entire grid collapse based on under frequency. So could it happen here? It can happen anywhere. As long as anytime you don't have enough generation to cover the load, you have the potential for under frequency and a grid collapse.
Well, you're thinking ahead. Thank you.
And I'll just tack on one of the kind of aspect of that, separate from renewables, is just natural gas in electricity coordination. So as we go to more natural gas power generation units, that demand for heating and electricity now start to fight each other. And so MISO in particular has been talking about that subject for over 5 years, because they saw this transition to more gas coming on the electricity supply side, and said, we're going to have to coordinate a lot better than we do now to make sure that when you get in these really tight, nasty cold events, that the system can remain stable. Electricity markets generally have been most concerned about the heat of summer, when the load is highest, but that dependence on gas now pushes some of those most critical times to the winter, which certainly is what we saw. And then those gas supply impacts can affect other parts of the country. So even though we didn't have an issue with people getting off going black here locally, there are other utilities in the Midwest and even in Iowa that saw huge natural gas bills. So as Doug said, thankfully with our units, we didn't see that because we did burn mostly coal, but there are some utilities that saw huge gas bills just because of the spike in that market during that event. Even though they were able to continue to supply, the cost went up significantly. So that's another aspect that we have to be very careful about going forward as well. And one other thing, comment I just want to make is, we've talked a lot about renewables and their limitations, and I want to make the point that, MPW is not anti-renewable in any way. We have, obviously, our strategic plan is to reduce carbon emissions significantly in the coming years and increase our renewable penetration. So that is part of our path forward. I think it's just really important that we understand, and we're trying to communicate with our customers about what the limitations are, what the risks are of that transition, and make sure that we do it in a very smart way so that our system stays reliable.
Hey, Rick, I just wanted to say one thing, just as a member of the Board of Trustees for the last few years. Gage and his team have been fantastic. They are top notch. Doug, Erica, and all the rest of them, just really impressive. And, obviously they're building on a foundation laid by our friend Sal, but they have really taken the ball and run with it. And they are great. I know this meeting isn't necessarily about the fiber to the home project, but sometime Erica can give us an update on how fantastic it has been. And particularly, she took the reins of that project and has done a fantastic job. And we are, so lucky to live in a community that not only has, great power and great water utilities, but now, we really have a state-of-the-art communication utility as well. And it's just amazing. And these guys do a fantastic job, day in and day out to keep all the plates in the air while they're trying to make all this stuff happen. So I've learned an awful lot being on the board, and just really impressed particularly by the executive leadership there.
Just
Thank
want
you
to
very
give a
much.
shout out to my old friends at Muscatine Power and Water. Great presentation, Doug. Very, very excellent. And I certainly agree with Keith, the leadership team with Gage there as general manager, and has really continued to get things done, getting the fiber to the home project completed. That's great. And this power supply study will be foundational for the utility for many years to come.
Yeah, I think he said that Sal laid a lot of that foundation. So he just had to hand me something really great, and I just got to not drop it as we go forward. So.
Rick, if you don't mind, I also wanted to pass along a compliment just from a person who works at a business sending a frantic email via your website, and being the person on my side of the business who answers those. I was extremely happy that I was answered promptly, thoroughly, and it wasn't like, that's a really stupid question, Jessica. If you guys knew me, you'd know that I ask a lot of those. So even just for that, whoever was on the other end of that was so professional, so prompt, and had everything taken care of. And then the follow-up steps were also followed up on. So I appreciate even that step. So it does show that the leadership trickles down to the rest of the group there. So thanks for that, you guys.
Awesome. Thank you.
Thanks, Jess. Appreciate your comments. And thank you so much, Doug, for your presentation. Very much appreciated. And Gage, thanks for coming on and sharing some comments as well. very much appreciate having a community partner like you in Muscatine. It's huge for, obviously, for the community. And so again, we really appreciate your time today. In recognition of your presentation today, the Rotary Club of Muscatine will be donating funds to pay for 20 children to be inoculated for the polio virus. So if we were meeting in person, I would hand you a bookmark to commemorate the occasion, but unfortunately we can't do that. So we do have some Rotary customized cloth face masks with the message that the Rotary Club of Muscatine cares, that we will get to you. So to commemorate your visit with us. So again, thank you so much.
Thank you. Thank you all.
Thanks for having us.
Absolutely. Just a couple of reminders for everyone. 1 week from today will be a fellowship meeting on the 15th. 2 weeks from today, our speaker will be Brian Ritter from the Nahant Marsh, speaking to us about endangered species research. And I think that's going to conclude our meeting. We're going to go ahead and finish with the four-way test. If you would please join me in stating the four-way test of the things we think, say, and do. Is it the truth? Is it fair to all concerned? Will it build good and better friendships? Will it be beneficial to all concerned? Meeting is adjourned. Thanks, everyone. Have a good week.
Thanks, Rick.
I know.